So, good morning, ladies and gentlemen. I hope you can hear me. We are here now in the session called Green Vehicles, Increasing Efficiency of Powertrains and Vehicles. A very, very important topic, as with the measures all around efficiency improvements of hybrid powertrains in particularly. We will be able to have a short-term impact on fuel consumption and CO2 emission reduction. And for that reason, of course,
do you have your mic open?
Yes, I have it open, and before everybody could hear me.
Next to your micro.
Can you hear me? Before it worked quite well. All the participants could hear me.
I can hear you.
Hello?
On my side. Thank you.
Peter, this is Eric. Yes, I can hear you very well.
Okay, good. So I continue. So in this session, we have two projects to be presented. The first is called Eagle. It is dealing with advanced internal combustion engine development, particularly for hybrid powertrains. Again, something which should have a short-term impact on fuel consumption reduction. And the same is true for Advice, the second project dealing mainly with hybridization, advanced concepts for hybrids, also with the main focus, of course, to improve the efficiency, as in the title of our session today. I will briefly introduce then our speakers when they will start with the presentation. Before we step into the presentation, and then we will have about 20 minutes of discussion, I would like to introduce our speaker from the European Commission. It's Eric Serandes, and so I would like to ask you, Eric, to give a short introduction to this session. Thank you.
Thank you, Peter, and good morning to all the participants, and welcome to you from myself. So, as Peter said, my name is Eric Serandes, and I'm project officer at INEA, the Innovation Network Executive Agency of the European Commission. So Peter already introduced to some extent the session. So as you know, for the next 20 minutes, we're going to hear about two projects, which are Project Eagle and Project Advice, both financed from a call from 2016, different calls. What they have in common is that they are both about hybrid powertrain / vehicle. But as you will see in their presentation, their perspective is very different. Project Eagle is focused on the internal combustion engine, how to improve its energy efficiency. The demonstrator we will see it is an engine, whereas for Project Advice, the focus is on the vehicle and the integration of the different architecture into the car. And we will see that the demonstrator, there are three demonstrators, which are three vehicles. Project Advice finished in September, whereas today is a special day for Project Eagle because it's the last day of the project. A very brief review on what we expect as European Commission from these two projects. So let's start with Project Eagle. The overall goal is cut emissions, but this has come down, of course, to some very specific targets. And I think it's important to remind them here before we start with the presentation. So first of all, the engine should achieve an energy efficiency of more than 50%. It should comply with RDE regulation Euro 6 with no conformity factor. The consortium has to measure PN emissions below 23 nanometers down to 10. And on top of this, the consortium should also demonstrate how the engine that they have developed could support the achievement of a long-term goal, which is to have a fleet target of 50 grams per kilometer of CO2. This is with the WLTP. For Project Advice, targets are different. So the focus is about the system. And in this case, the project has to demonstrate that the solution to develop could deliver a reduction of cost at system level. I'm not going to talk about the specific targets. This will be done during the presentation. It is also about fuel economy of 20% over the WLTP, compliance with RDE regulation. This is, in this case, it is with a conformity factor of 1.5, reduction of emissions, cost reduction, and of course, drivability of the demonstrator should be ensured. So this is a very brief overview, also to set the scene in terms of our expectation with regard to these two projects. Peter, if you can hear me, I would say the floor is back to you. So this is all I wanted to say as an introductory talk. Thank you.
Thank you very much, Eric. This was quite informative for our audience, I guess, to get an impression what they're gonna hear in the two presentations. Now there will be two videos available, and after these sessions, the speakers, respectively, those who have recorded the video, are available then for questions. So with that, I would like to step into the first project, Eagle, as already mentioned, on engines. It is my pleasure to introduce the speaker. It's Jean-Marc Zaccardi from AFP Énergie Nouvelle from France. He's project leader, and as mentioned, he will be available after the video during then the Q&A session for further questions. So let's start. Thank you very much, Bernhard Brandstetter. Now we step into the discussion. Immediately, I would say we should step into the discussion because of the limited time. First, my question, if our colleague from INEA has maybe a particular question. Eric, if you're still online. This is not the case. I would like to remind that in case of the advice project, we probably will also have the project coordinator, Lars Olaf Carlsson from Volvo online. I may start with the questions, if you don't mind. Jean-Marc, it was quite interesting to listen, of course, the advantage of hydrogen diluted fuels regarding faster combustion and therefore improved efficiency. Very simple question, where to get the hydrogen from?
Good morning. Can you hear me well?
Yes, I can hear you very well.
Thank you. So in the frame of this project, we've considered two different approaches. The first one, obviously, is to use a specific tank for that. But we looked more into details in two different solutions also, which is fuel reforming, so onboard reforming to produce hydrogen, and also water electrolysis. So these are the two solutions that we've investigated. Unfortunately, as of today, it seems that none of them is particularly relevant, let's say, because fuel reforming means a huge penalty in terms of efficiency and so fuel consumption and CO2 emissions. This is the main hurdle for this one. And the second one for water electrolysis is the packaging constraint, in fact, because even for small amounts of hydrogen, you would have to implement on board quite a big equipment, let's say, to proceed with water electrolysis.
Easy to imagine. So if very obviously hydrogen, I mean, is a good fuel basically for internal combustion engines as well. The combustion systems which you have investigated and developed, including also, but maybe pre-chamber is then less necessary, or how would you see if, in example, pure hydrogen would be available in the future?
Of course, you could have two different approaches, let's say. The first one with hydrogen. If your objective is to run in lean conditions, you could use hydrogen as a supplemental fuel or as a single fuel without any pre-chamber. And on the other side, if you do not want or if you cannot use hydrogen, then you can still consider the use of an active pre-chamber to run the engine in ultra lean conditions. And in that case, it would work without hydrogen.
Interesting, the approach with the pre-chamber. You have mentioned that. And it is obviously it was a concept which also was investigated previously. Pre-chambers always also have a little bit the challenge of heat losses. How do you manage that, and also durability, of course, of this very from let's say from heat thermal loading, very highly thermally loaded parts around the pre-chamber. How do you see that?
That's a very interesting question, because the pre-chamber is very promising, but as you mentioned, there are some significant challenges. So heat losses is one of them, especially in lean conditions, because your objective is to reduce the heat losses, but the pre-chamber is a small volume which is operated close to stoichiometric conditions, so which means potentially some high heat losses. So you have to be very careful when you design the pre-chamber and the cooling jacket around the pre-chamber. That's one first thing. Durability is also a concern, because inside the pre-chamber you also have a fuel injector, and so you have to control very precisely the injection process inside the pre-chamber if you want to avoid any fouling inside the pre-chamber and also of the pre-chamber holes. So you have to be very careful about that, and it requires a lot of effort if you want to make it run properly. And I would like to mention as well that it could also have some consequences not only on efficiency but also on pollutant emissions, because even if the pre-chamber is quite a small volume, it can have a significant impact on engine out emissions.
Okay, thank you. Maybe a very last question, which guides then also to the second project. You have a high pressure stage of your charging system, which is driven by an electric motor. So I would assume this is maybe kind of a statement that this kind of concept would require a full hybrid, or at least a hybrid with high power with a 48 volt. Most likely would be difficult.
Yes.
Okay, thank you very much. With that, I would like to switch now to the second presentation, to the advice project.
Sorry to interrupt. I don't know if you noticed, but there are some questions for Project Eagle in the chat box.
Okay.
Maybe a quick one, considering the speed at which peak efficiency was achieved for Jean-Marc.
I've seen that question. So this is our main target. I mean, the speed 120 kph. I mean, this is really our main target to improve the efficiency where the engine is used, especially for a PHEV application. So this is not a low load, low engine speed conditions, but it would correspond roughly to this kind of motorway condition. So in these conditions, we are trying to optimize the efficiency, and the target, which is 50% brake thermal efficiency, correspond to this kind of vehicle speed.
Thank you.
I can give more details to Mr. Maggiore in the private chat.
Thank you. Honestly speaking, I have a little bit of a problem to see the questions in the chat. So also looking at the time, I would like to switch now definitely to the advice project. Because it was just the question now about the electricity requirement of the high pressure charger. So we have seen three concepts also in the advice project, which, if a simple question, if you would have the Eagle engine available, in which of the concepts would be best to fit it in of your hybrid powertrains?
Well, the Eagle engine, I would say would be best in either the full HEV or the plug-in hybrid.
So with that, we could probably boost again the efficiency of the concept. What was also interesting to see the approach with eco routing. I mean, eco routing is not something new, but the interesting point was, the question would be: have you investigated that eco routing with the three different concepts, with the three different hybrid concepts, and for which of the hybrid concepts did it work best, or is there any difference?
Well, the difference is, of course, between eco routing and the normal the normal routing, and you can imagine that, and this is also the novelty of the eco routing we have implemented, that hybrid powertrains, especially the ones that we have been investigating, are much more complex than conventional powertrains, and also powertrains relying solely on electrical drives, because we have much more degrees of freedom, and therefore, of course, the eco routes will be a little bit different for all the different powertrains, but you get significant gain in efficiency.
So for significant gain means approximately the same for all?
You do not have this, the same strategy and the same eco route for all the drives.
Yes.
They will be different, of course,
Yes.
in terms of length and time, but you get roughly the same results.
It's interesting because with the 48 volt, one would expect, let's say, in terms of recuperation, that you have less potential than a full hybrid with a much larger e-motor with a much larger battery.
No, especially the 48 volt system works quite well in terms of efficiency.
Very interesting. Also, what was interesting to see that you have investigated a heat storage system. Did you, maybe I didn't get the point in detail, did you investigate it also for all the different hybrid powertrains, or for a special
No,
one?
we have investigated this system for the PHEV and also for the HEV demonstrator via simulation. First, we conducted some experiments on the test bed with this component and seeing how this component works in reality. We performed some measurements, and then we calibrated our simulation models, and we saw really some potential in keeping the engine at a constant temperature level, and also the battery in a well-being condition for the battery.
That exactly would have been my question now, because the heat storage systems have been investigated for engines in previous projects for quite some time ago, but frequently. But I haven't seen as much that for the climatization of batteries. So let's say, talking to the heat storage capacity needed for a large battery, what would be relative to the energy electrically stored in the battery in kilowatt hours?
Well, it's I cannot give you numbers here, but the main point is here to keep the battery always at a nice temperature for the battery, and this increases the lifetime of the battery. So that's the main point here.
Very obviously, yeah. But it was always a little bit of power or energy density of the heat storage systems which they suffer from. So it was,
yeah, sure.
It would be interesting to see this relation between the electrical energy storage and the heat storage. Well, we are approaching the end of the session. I don't know if someone sees an interesting question in the chat. I have to apologize. When I click here on chat, I don't see too much of questions. Else, I would suggest that if there are any further questions, you have got the contacts of our speakers today. I would like to close now with many thanks to both speakers, to the very interesting presentations, and looking forward to hopefully seeing you next time again in Brussels. Thank you. Bye-bye.
Thank you.
Thank you.
Nice day.